And now we're going to look at the idea of mutually exclusive events. And mutually exclusive means it's impossible to occur at the same time. Okay? So think about flipping a coin. If you go ahead and flip a coin, you're either going to get heads or you're going to get tails. But there's no way you could get both. Absolutely no way. Okay? So when we're going ahead and looking for OR probabilities, and we're focusing mostly on the ORs, okay, of mutually exclusive events, the probability of A and B occurring, okay, I'm sorry, probability of A or B occurring, okay, is equal to the probability of A occurring plus the probability of B occurring. Okay, so we can have either or, but we can't have both at the same time. Okay, you can also see it like this: A union B. Remember this notation from previous chapters is also equal to the probability of A plus the probability of B. Okay, so we got to look at these as separate things. They can't occur at the same time. We can't flip heads and we can't flip tails at the same time. I'm going to go ahead and look at example 7, and it's on page 134. Okay, and if you roll a single 6-sided die, okay, I want the probability of either getting a 4 or a 5 on this die. Okay, now each side of the die has a probability of 1 over 6. Okay, so the probability of getting my 4 is 1 over 6. My probability of getting my 5 is 1 over 6. When I add them together, I get 2 over 6 or 1/3. Okay, so you're just going ahead and trying to figure out if you can get both of these things and just add them together. Okay. Now if we want to look at the same idea, but they are not mutually exclusive. Okay. Okay. These are AND events. Okay. And A and B are not exclusive events. Okay. These are a little trickier. So we want to look at the probability of A or B, the probability of A occurring, added to the probability of B occurring, minus the probability of A and B. Okay? And I'm going to go ahead and look at example 9. All right? And I have a group of 50 students. 23 take math. 11 take psychology, and 7 take both. Okay. If one student is selected at random, I want to find the probability that the student takes math or psychology. Okay. So the probability of the student taking math is going to be 23 over 50. The probability of a student's taken psychology is going to be 11 over 50. And those get added together. Then I'm subtracting the probability that they're taking math and psychology. Okay, and that's my 7. So subtract 7 over 50. And I end up with 27 over 50. Okay, so you'll have, it's very similar to when we did the Venn diagrams where, two people were doing the, people were doing both things, or they only liked one thing, or they liked all three things. This is kind of the same idea. Okay, so there's a group here that's going to be doing both the events that you're looking at, the probability of both those events happening. Okay, I'm going to go ahead now and I'm going to jump over to example 12. And this is on page 136. And here we have a chart here, and I want to express probabilities as simplified fractions or decimals and decimals rounded to the nearest hundredth. So we need to do both fractions and decimals on this one, so pay real close attention to the directions on your homework. Okay, and it's a chart that we have here, and I want to look at part A, and I want to know that the person is married or female. Okay, so married or female. So if the people that are married, if you look at the bottom, you have a total. Now, it didn't differentiate, just said any person that is married. So the probability that they are married, the total is 133, and our total number of people surveyed is 254. My probability that they are female, so I need to go across my row, my female row, and my total of females is 131. And I'm also going to put that over my total, 254. And then I need to subtract both. Okay, so females that are married. Okay, so if you go to the first column, second row, 67 is the number of females that are married. So we got to exclude those out and subtract them over my 254. When I put this in my calculator, I get 197 over 254. And this is a simplified fraction. Okay, and they said also excluded as a decimal rounded to two places, so it's 0.78. Okay, if I go ahead and look at part B, the person is divorced or widowed. Okay, so the number of people that are divorced, if I go down the divorced column, is 26 over my 254. Widowed is 14 over 254. They didn't care about gender in this case. And are there people that are divorced and widowed? That's not even a category. So there are 0 people that are both divorced and widowed. Okay, that information's not available. That means it's a 0. Okay, and that goes ahead and simplifies to 20 over 127 as a simplified fraction, which is about 16 hundredths. Okay, so go ahead and try the other ones. Let me know how it's going for you, and we're going to go ahead and wrap chapter 11.6 up on the next video.